Hi, and welcome back to part 2 of our discussion on centroids. In our last video, we went over some of what a centroid is, what centroids used for, and then some of the basic equations for our three shapes you see on the page in front of you, our square or rectangle, our triangle, and our semicircle. Now we're going to go through just some simple problems on how to find the centroid of these shapes when you have actual dimensions in front of you. So we'll do this simple calculation for the three of these, and then we'll do a more complex problem in our next video. So, looking at our square and rectangle, before we look at our dimensions, let's write down what our equations for the square rectangle centroid location is. And if we're looking in our x direction here, that's going to be our base divided by 2. So if we plug in numbers for that, our base is 10, so 10 over 2, our x bar is equal to 5. And once again, make sure you are labeling our centroids as x bar and y bar. So for y bar, it's our height divided by 2. So if we plug in, 4 divided by 2 is equal to 2. So if we draw that into place, we can count. Again, we always start from our set point. I like to set my point of 0, 0. Think of it as a graph. 0, 0 I always like to set as my bottom left corner of whatever shape I'm working on. That includes when we get into complex shapes, which is going to be important, that you always have a 0 point you're basing off of. So my 0 point is the bottom left here. I'll go 1, 2, 3, 4, 5 for my x, 1, 2 for my y, and my centroid will be centered around there. I will mark it using my centroid drawing. It's not perfect, but it gives the idea of what the centroid looks like. Let's move into our triangle. So once again, I look at my shape. It's a right triangle. I need to make sure that it is considered that, so I better write that in there. We can't just do any triangle. We have to make sure it's a right triangle. So if it's a right triangle, I look at my base first, and so for x bar, it is base divided by 3 for a triangle. So if I plug in my base value, I have 6 over 3, and that would be equal to 2 then for my x bar. For y bar, it is height over 3. I look at my height, 3 over 3, so that is 1. And once again, with our right triangle, we always find the right angle. So your 0, 0 point, or wherever your centroid is located, always has to go from our right angle, which is right here on this one. So that's my 0 point. So for my base, I count over 1, 2. For my height, I move up 1. And right here is my centroid for this shape. Hey, I drew that a little bit better this time than my last one. So there we go. Practice makes perfect, I guess. Alright, so now we have our rectangle, our triangle. Now let's do our semicircle. So if our semicircle is set up this way, and for any of these problems, orientation matters. So x bar is always going to be looking from left to right. Y bar will be looking up and down. So if it was flipped on its side, you would have a little bit different setup. But I digress. Here we go. X bar in this setup is just going to be our radius. So our radius of our diameter here is 4. If our diameter is 8, our radius is 4, which is also I gave the dimension there for the height. So that's my radius in this setup. For my y bar, my equation is 4r over 3 pi. And so let's see if I can plug in. So 4 times 4 divided by 3 pi. Let's see if I can get my calculator to show up clearly to show you how I like to do that. So if I am doing this problem on my calculator, I always make sure, just to be safe, that I use parentheses. So I'll do parentheses 4 times 4, close the parentheses, divided by parentheses again, 3 times pi, close those parentheses, and hit enter. And I get 1.6 I guess you could say 1.70 if you want to for rounding purposes. Either way, we get the answer. So if I go my radius of 4, 1, 2, 3, 4, and I go 1 and 0.7 is going to be somewhere in here, let's say. There is my centroid for my semicircle. So those are putting our 3 equations we learned from our presentation into practice. In our next video, we're going to combine these shapes into a more complex shape and show how we can find the centroid when we have multiple shapes together in a complex shape. So make sure you come back for the excitement that will ensue there. We'll see you soon.